Good morning, everybody. I'm really delighted to see you all here in person after a long time, and it's my utmost pleasure to present the all-new 11th generation Civic e-HEV to you today, on behalf, of course, of the entire development team. Before we actually deep dive into the technical details, just let me briefly explain one thing, which has been applied for the first time at Honda on a global model. We have defined all our dynamic performance attributes based on European requirements, and this is something new we have performed. As we believe the European environmental conditions, and this includes the driving pattern, the infrastructure, is the most stringent in the world. So this means a car that works in Europe, we believe also works around the world. And the other characteristics then will be adapted and optimized for each region accordingly. So this gave us also the opportunity to really implement technical solutions from scratch, which wouldn't be possible if we would have had an adaptation to the European market later on. Starting with package, some dimensions as a comparison to the actual current Civic. What I wanted to say and emphasize here is that the car hasn't got that big. It's 31 millimeter longer, and also the wheelbase has grown by 35 millimeter, but this 35 millimeter was completely allocated to legroom for the rear passengers. The width is still the same, slightly wider track, and the roofline is lower than before. And what I wanted to say is that actually we managed to incorporate the complete full hybrid electrification into this car without noticeable sacrifice in space utility. Some interior and design features. I think during the static presentation we've already talked about the outlets, the air outlet as a design feature, but it also has a very important functionality. With this new layout, we're capable in distributing the airflow in a much wider angle, and with this we can actually avoid the air hitting the passengers directly, for example, in the face. Tactile textures, of course, also a very important aspect where we've put a lot of emphasis on for enhancing perceived quality. For example, the door handle has been shaped very ergonomically from the inside so that you have a very good finger insert. Then all the force feedback, click fields, spring forces for the dials and levers, and of course a very careful selection of materials where you are in contact frequently. The power meter, this is a new feature we're introducing at Honda, especially for the hybrid models. It indicates a certain analogy to the ref counter, if you want. On the left side, the power output is being displayed. The numbers represent the percentage of the maximum power output, and with rising speed also the power output is increasing and gives a certain correlation to the driving sensation. We have separated the acceleration phase and the deceleration phase in order to also maximize the utility, especially also for the deceleration phase, because then you have that green bar increasing if you increase your brake energy recuperation, and with this you can really maximize to regenerate all that brake energy in order to maximize also the efficiency of the car. Just a few words for the operation for the full graphic meter. So very simple, left-hand side switches on the steering operate the content of the display on the left side, and the right-hand side switches do for the right-hand side display accordingly. In the middle, the information regarding Honda Sensing will be displayed, so I think it's quite easy to understand if you want to change the content. Now let's move over to the powertrain, the heart of the Civic e-HEV. These are the major specifications as the maximum output of the e-HEV is performed under a so-called series hybrid configuration. The maximum output of the hybrid system consists of the electric propulsion motor, which is 135 kilowatts and also 315 Newton meter. This is a comparison of powertrain variants against the current Civic. As you might remember, we had 3 engine variations. We had a 1-liter 3-cylinder petrol engine, a very fuel-efficient one. Then we had a very high-powered 1.5-liter turbo engine with 184 horsepower. And then we had the diesel with 300 Newton meter of torque. Now we've been asked why the new Civic has only just one powertrain, just one hybrid powertrain. And here's the answer and the explanation. With this e-HEV, we are actually covering the complete engine lineup range in specification of the current Civic, consuming less than the 1-liter, emitting less CO2, having more power output than the powerful 1.5-liter turbo, and even more torque than the diesel. So from that perspective, we're quite happy to have this one and only powertrain. These are the hybrid components. Of course, it's very important to look at the components when improving the dynamic performance of the hybrid system, but it's also important not just to look at the electric components. It's at minimum as important as looking at the electric components, also to think about the combustion engine. And this is exactly what we did. So we have newly developed a 2-liter direct injection Atkinson cycle engine with a 41% thermal efficiency, which is an industry-leading figure. Then we have improved the existing e-CVT. This consists of the 2 electric motors, the generator and the propulsion motor from the CRV. We have made it more compact in order to actually incorporate it in the Civic engine compartment. Then we have the PCU, a power control unit, a very important component of the hybrid system, which manages and controls the high voltage energy to be supplied to the electric motor, which has seen also a power density increase of 12%. And last but not least, the IPU, which incorporates the battery, obviously. This has also seen a significant improvement in performance on one side, but also in space and volume. So it has become smaller, lighter, and as a result, the energy density has increased by 46%. Now, talking about the 2-liter direct injection engine, which is newly developed, we're applying a high-pressure injection system with the possibility of multiple injection. Now, the multiple injection, of course, brings loads of benefits because we're capable in separating the whole injection quantity in several injection steps, up to 4. And this can be performed within one suction stroke. And this brings advantages in the fuel spray atomization, which then also leads to a much better and much complete combustion than with conventional systems. This, of course, is supplied but also supported by the high flow intake ports, which is creating a lot of tumble movement in order to have a very good mixture, a homogeneous mixture within the cylinder, again for good emission behavior and good combustion for effective combustion. As a result, you can see on the right side a comparison of the power output line between the port injection engine, which has been used for the CRV, and the blue one, that's the newly developed DI engine. The torque has increased, and this is very important later on to improve the drivability, which we will explain in a second. Engine efficiency map. I love engine efficiency maps. As you know, this is a direct comparison of the engine efficiency map between the former port injection engine and the 2-liter direct injection engine. And I think it's obvious that you can immediately see the difference, that the bluer, the better, of course, that this blue area has increased a lot for the direct injection engine to higher loads and to higher RPM. And this, of course, brings benefit in the drivability, because now we are actually capable also to maintain very high efficiency in this area, which was not possible before. We had to, for example, switch back to the hybrid mode in order to be efficient. And that comes from the fact that we are actually injecting the fuel directly into the cylinder. So this is efficient in the first place. We are not spilling anything, but we're just putting all the fuel into the cylinder directly. And secondly, we're actually utilizing the evaporative energy of the fuel, which is sprayed directly into the cylinder, to cool the cylinder. And by cooling the cylinder, it is capable in incorporating more oxygen. And more oxygen means more torque, because we can inject more fuel in order to produce more torque. But the cooling of the cylinder also brings another very important advantage. It is pushing away the knocking limit. And knocking has always been the reason why in port injection engines we had to perform fuel enrichment, but also we had to retard the ignition timing, which all together is decreasing the efficiency. And this now is not necessary anymore for the 2-liter direct injection engine, so that we can stay stoichiometric all the range, and we can also maintain advanced ignition timing. And this is the secret behind that we have a much bigger range of high efficiency. Here again, the e-CVT and the PCU. e-CVT, let me just briefly once again emphasize that I am also personally not particularly happy with the expression e-CVT, because it suggests and associates that there is maybe a CVT gearbox in play, which is not the case. There is absolutely no gearbox used whatsoever in the HEV hybrid system. And this is a very big misunderstanding, which I still read from time to time, that the Honda e-HEV hybrid system is utilizing some kind of gearbox, which is not the case. e-CVT, what does CVT mean? CVT means continuously variable transmission of torque. And of course it's modulation, and this is done completely in an electric manner. This means by changing the amount of electric current, by changing the ampere, just like a electric car. And this is exactly why it's called e-CVT, but it has nothing to do with the CVT gearbox, once and for all. I think that is clear now. PCU, we're not just looking for improvement in performance, but we are also trying to, for example, replace rare earth like copper. Copper is becoming more and more precious metal, and it's the first time at Honda that we are replacing the high voltage strand of copper by aluminium, and the connection between the PCU and the IPU now is an aluminium strand. Then the IPU, the Intelligent Power Unit, which incorporates the battery. Now there is a very important aspect which has been improved, which also makes many things possible now in the drivability. First of all, of course, battery material technology has evolved. So we have applied new material within the battery cell in order to improve and increase the durability. But the second aspect is that maybe you know, maybe you don't. Honda has been the first manufacturer to introduce a hybrid model on the European market. And this is also the reason why we have a very big amount of database of how batteries are being used in the market. And actually we have now utilized all these data. We've been utilizing it before, but now we are really confident because we have now also introduced a lot of e-HEV systems that we can minimize the margin we have been reserving in order to maintain and fulfill and assure the initial vehicle performance also after lifetime of the vehicle. This is a very important philosophy of Honda. We do not want the customer to suffer any deterioration in performance after the lifetime of a car. So with that in mind, we are now expanding the usable capacity of the battery. What does this mean? This means that we have now much more electric energy and much more electric power available for the electric assist and the electric boost while operating the hybrid system. And this brings a lot of benefit, which I will explain now, utilizing maybe some different driving situations. But before that, just as a summary, the performance trade-off between fuel efficiency and 0 to 100 kilometer acceleration. And the e-HEV Civic does not just exceed the 3 engine variations from spec perspective, as I said before, but also in performance. So it's consuming less fuel and is even faster than the 1.5 liter turbo Civic. Now, as I said, I'm going to explain the improvement in drivability utilizing maybe 4 different scenarios where you can definitely feel the improvement. First is the urban area, and I think it's quite obvious with the electric motor as the primary drive source. You have an instant torque available, and you also have a very responsive increase in acceleration g-force, and this is one of the speciality of an electric motor. The second situation is maybe when you exit the city driving on a rural road. Again here, the instant rise of the acceleration g-force is a great benefit of utilizing the electric motor as a primary drive source. But on top of that, we also utilize the so-called linear shift control. And now this linear shift control, this simulates a gear shift. Even though we are not utilizing a gearbox, we are simulating a gearbox. Why? Because the human wants to have a certain natural correlation with speed. So with increasing speed, we are all expecting also the engine speeds to rise. And if that is done in a manner that it sounds like a very close ratio sports gearbox, that is fantastic. And this is exactly what is happening. And we are underlining that with the subjective, we could call it the perceived acceleration by, on one hand, the power meter indicating the increase in power, but also with the active sound control. And the active sound control gets on if you do the acceleration in sports mode. So I really recommend everyone today on your test drive, please perform an acceleration in sports mode in order to really experience this linear shift control together with the active sound control, which is activated after a certain or at a certain RPM. And to be honest, I never thought this was possible, but it brought back some VTEC feelings, really. Okay, The third situation is winding, and we have also selected a nice portion of winding roads on your test drive route today where you can really experience this. The winding control, this is a system, a new system, which actually detects whether you're actively driving a winding road. And with sensing the lateral G, it then at a certain moment switches on the winding control and then keeps the engine speed. For example, when you brake into a corner, during cornering, it is keeping the engine speed on a certain level so that at corner exit, you have exactly the matching RPM to have a very smooth re-acceleration and exit out of the corner. This is also something I would really recommend you to try out. And then, last not least, motorway. I have to be honest, the e-HEV hybrid system had some weak points, and that was when accelerating strongly on motorways. On motorways, the situation is already quite difficult because due to the high aerodynamic resistance, the base consumption or the base request in power is already quite high, and from that point you are now performing an acceleration, so it's a very severe situation. However, as I explained before, with the increase in performance of the direct injection engine and the much higher amount of electric assistance and boost we are now capable in performing. For example, when accelerating from 100 to 120, in the former system, we would have left the engine drive mode and we would have entered the hybrid drive mode where the engine is revving up in order to provide the electric power. But now we can stay in engine mode because we have much more power from the engine and also much more boost assistance from the electric components. And that brings a very relaxed and very smooth driving on motorways, even if you want to overtake cars at higher speed. So this is certainly something where the Civic e-HEV has seen a great and significant improvement in drivability. Please try that out as well. As a summary, it's not just important to improve electric components, but it is really also important to think about the engine, and this is why Honda, as the world's biggest power unit manufacturer of the world, has put all their knowledge and all their competence into the development of the new DI engine, and that has resulted, from my opinion, in a fantastic hybrid system overall. Good dynamic performance can not only come from the power unit, it also needs to be supported by the chassis, and that was also the reason why we've implemented loads of new, let's say, measures in order to improve the chassis dynamics. If you put it in a nutshell, it's a little bit small. It's like this, that we have improved the geometry of the suspension, but also from the whole car. We have lowered the center of gravity. We have reduced all the possible friction of suspension arms and joints. One big thing, in my opinion, is the improvement of the EPS control paired with the stiffness of the steering system itself. So the EPS control has seen an increase in sampling rate by a factor of 6. So it's 6 times faster, really, to control the EPS support. And this you can definitely feel, especially around on-center. The steering is precise, but also extremely stable. Body rigidity, not just a handling measure, but also very important for noise vibration and ride comfort, so that the suspension can work effectively. We have increased the torsional rigidity by a total of 22% by incorporating reinforcements, structures around the body in white, but also increasing the application of structural adhesives 9.5 times more than the current Civic. And now we are actually on a level of the Civic Type R. And adhesives, as you know, is a very effective measure in order to improve rigidity without increasing the weight. But these kind of things, these are exactly the topics which became possible first because we were looking at European dynamic performance requirements from the beginning. Otherwise, later on, to perform this wouldn't be possible. So this is just maybe one lively example for that new development process. Tailgate was made out of resin, reducing 20% in weight, and the hood is made out of aluminium, reducing 43% in weight. And as you know, probably it is very efficient to reduce the weight at the end of a car because this is reducing the moment of inertia when turning. Honda Sensing, basically two new features. One is the adaptive driving beam, which is an evolution of the current active high beam, and the traffic jam assist, a function which is supporting driving in a traffic jam. The whole system has seen some system updates already against the HEV because Honda Sensing is a basically improving system every day. Traffic jam assist, the difference to the current system is that now also the steering operation, not just accelerator brake, but also the steering operation is performed down to standstill. Adaptive driving beam, this is utilizing a variable light distribution technology in order to control a lower side high beam and a higher side high beam in order to reduce glare and dazzling pedestrians or oncoming vehicles. Crash safety technology, 11 airbags in total, some updates on seat belts like pre-tensioner, lap pre-tensioner, and then some new structures also for the pedestrian protection structure. Two equipments I would like to emphasize. One is the Bose audio system, the Bose Centerpoint, 12 speakers in total. This system is equipped in the so-called advanced grade, and if you have the chance to maybe listen to it with your own favorite music where you can have a direct comparison, please try this out. It's really a fantastic audio system. And then we have the drive modes, Econ, Normal, Sports, and now as a fourth, the individual, where we can also customize a little bit the parameters for both powertrain, steering, and also the indication. So as you know, with the powertrain, it will sharpen a little bit the response of the accelerator pedal. Good. I think that's basically it. As I said, the driver's hybrid, I think it's really a great improvement in respect to drivability. And really, to be honest, I didn't expect to have that high level of drivability with a hybrid system. And believe me, I'm really a petrol head. I'm wearing a piston around my neck all day. And even though I was really fascinated by this car when I drove it the first time. So I hope you will also enjoy your test drive today.